Have you ever wondered why square numbers are so important in mathematics? Well, let's delve into the intrigue of square numbers. These are not just ordinary numbers, they are those special numbers that you get when you multiply an integer by itself. Picture this. If you take the number 1 and multiply it by itself, you get a square number. That's right, 1. Now let's try this with the number 2. Multiply 2 by 2 and voila, you get another square number, 4. Now, if you're feeling adventurous, let's take the number 3, multiply it by itself, and there you have it, 9, another square number. This pattern continues. 4 times 4 gives us 16, and 5 times 5 gives us 25. These are all square numbers, and they play an integral role in a variety of mathematical calculations and real-world applications. Square numbers might seem simple, but they hold a lot of power in the world of mathematics. Squaring a number is like creating a perfect square. It's a symmetrical, balanced process. Imagine a number as a line of dots. When we square it, we're turning that line into a square made of dots. For instance, 4 dots in a line become a 2 by 2 square when squared. This act of squaring is a cornerstone of mathematics. It's in your formulas, equations, algorithms. It's the secret sauce in Pythagoras' theorem, the key to unlocking the mysteries of parabolas in algebra. And it's not just about numbers on a chalkboard. It's also an essential tool in engineering, helping us calculate areas, stresses, and forces. Computer science uses it to sort data, find patterns, and make predictions. So whenever you square a number, remember you're not just performing a mathematical operation. You're participating in a grand mathematical tradition. You're creating balance, symmetry, and a sense of perfection in a world that sometimes feels anything but. But where do we see these square numbers in our everyday life? You'd be surprised. Let's start with something familiar, the area of a room. When we measure a room, we square the length of one of its sides to find its total area. This is a practical application of square numbers in our daily life. Moving on to greater distances, even space exploration uses square numbers. The Pythagorean theorem, which is all about square numbers, helps astronomers calculate distances between celestial bodies. Now let's delve into the world of statistics. Square numbers are used in calculating standard deviations, a crucial concept in making statistical inferences and predictions. Ever marveled at the clarity of digital images and computer graphics? Well, guess what? They are all about pixels, and each pixel is a square. Each square pixel contributes to the bigger picture, literally. Square numbers, then, are not just abstract concepts, but tools we use to navigate and understand our world. Square numbers, though seemingly simple, are incredibly powerful in their application. These numerical gems are more than just products of a number multiplied by itself. They form the backbone of many mathematical concepts and prove instrumental in a myriad of real-world applications. Just think about it. You've seen them in the geometric patterns of a checkerboard, in the architecture of pyramids, and even in the spirals of a sunflower. They're not just hiding in textbooks, but are woven into the very fabric of our universe. Understanding square numbers can significantly improve your problem-solving skills, fostering an analytical mindset. They are tools that mathematicians, scientists, and engineers use to unlock the secrets of the universe. So the next time you encounter a square number, remember it's more than just a number. It's a key to unlocking the mysteries of mathematics and the world around us.